Right, welcome Ichak Solution. This is Vector 2. So in this lesson we are going to be finding the perpendicular distance from a point to a line and the coordinates of the foot. Alright, so I would encourage you to go and look for the previous lessons on vectors so that you can see the progressions of the lesson here. Alright, so let's go here. So if you have a line that we have here and you have the coordinates P here, so we can find the shortest distance from the point P to this line here. So what it actually means here, it means the vector from point P to this coordinate and this line here will be perpendicular to each other here. So we are going to be having F is the coordinates of the foot of the perpendicular from the point P. Then A is a fixed point on the line. Then the line will be given by R is equals to A plus lambda D. So which means we can find the coordinates of the foot here, since the coordinates of the foot will be equals to A plus lambda D here. So what it actually means, it means that there's a parameter that we can put into the equation of the line such that we can find the coordinates of the foot here. Alright, so we have stepped here that I've outlined on how to find the perpendicular distance from point P to F, and also finding the coordinates of the foot here. Alright, so the first step here we are saying you find the vector PF in terms of the parameter. So you find the vector PF in terms of the parameter. So PF is OF minus OP. Then the next thing that we do is to find the parameter using the fact that PF is perpendicular to the line. So which means the vector PF and the direction of the line, the dot product should be equals to 0. So that will be the condition for the parameter at this point here. So we can find the parameter there. Alright, then the next step is to find the distance of the vector PF. So we just substitute our parameter into vector PF and find the modulus of PF here. Then also we can find the coordinates of the foot. How do we find the coordinates of the foot? To find the coordinates of the foot, we just go with our parameter and substitute into the line here, which is R equals to A plus lambda T here, because we already have the parameter here. Or you just substitute into the general point, because the general point here will be also equivalent to the to the line here. Alright, so let's go to the example that we have here. The line L is the vector equation. R is equals to 2 minus 1, 3 plus T, then 3, 1 minus 2 here, which is our direction. Alright, find the perpendicular distance between the point P, 5, 18, 3 and the line. Alright, then item 2, find the coordinates of the foot of the perpendicular from a point P here. So let's go on the diagram and see how it looks like here. Alright, so our scenario is like this. We are having the coordinates of P here, and we also have the coordinates of the foot F here. So you can see PF is perpendicular to the line. So now we can now take our point. So our point is 5, 18, 3. Then F, the coordinates of the foot here, which is also the general point. So the general point is equals to 2 plus 3t, then minus 1 plus t, then 3 minus 2t here. That's your general point, and this is the coordinates where we need to find the distance from, the shortest distance from this point to the line. Right, so now we are going to find vector PF in terms of the parameter. So you can see PF is equals to this vector minus 5, 18, 3 here. So if you subtract here, we are going to have minus 3 plus 3t, then minus 19 plus t, then 0 minus 2t here. So you can see this vector now is the vector PF in terms of the parameter. So PF in terms of the parameter. So we know that PF is perpendicular to the line here. So which means PF dot the direction line should be equals to 0 here. Because for us to find the shortest distance, we need the perpendicular distance. So we are just going to find the dot product between PF dot the direction equals to 0. So from there we can now find the value of t. So which means we are going to have minus 9 minus 19 plus 0 plus 90 plus t plus 4t here. Alright, so this is now what we have. Alright, equals to 0 here. So now we can find the value of t here. So which means 14t is equals to 28. So t is equals to what? Is equals to 2. So which means that the value of the parameter at this point f here is t is equals to what? Equals to 2. So what we are going to do with t equals to 2, we are just going to substitute into pf, since we need to find the vector what? The perpendicular distance from P to the line here. So we just need to find the vector PF and find the modulus of PF. So vector PF, we are going to substitute T is equals to 2 into vector PF here. Alright, so PF, that was subtracting the general point minus the coordinate where we need to find the distance from. So that's vector PF. So we substitute here. So we are going to have 3 minus 17 minus 4 here. So now the next thing, we now have our vector PF. So we need to find the modulus of what? Of PF. So modulus of PF, we know that it's the x component, which is 3 squared, plus z component, y component, which is minus 17 squared, plus the z component, which is minus 4 squared, under the square root. So this will give us root 314 units here. So that's the modulus of what? Of PF. Alright, so let's go to the second part here. So the second part here, they are saying find the coordinates of the foot of the perpendicular from point P here. So we need we have a point P here, and the perpendicular from point P to this foot here. So we need the coordinates of this point here. So already we know that f is equals to 2 plus 3t, then minus 1 plus t, then 3 minus 2t. And we notice that the situation where PF is perpendicular to the line here, t was equals to what? T was equals to 2 here. Alright, so we just substitute the value of 2, the parameter t into f here, so that we can find the coordinates of the foot. So if we substitute, you are going to have 8 1 minus 1 here. So this is the coordinates of the foot here. So the coordinate of the foot is 8 1 minus 1 here. Alright, so let's go to the next example. Alright, so this is our next example here. The line is the vector equation r is equals to 2 minus 1 3 plus t 1 2 1 here. Then the first part here, find the shortest distance between the point A 302 and the line. Then item 2, find the vector equation of the line passing through a point A and is perpendicular to L here. So let's see here what it looks like here. Alright, so we have point A and point F here. So A is the point where we need to find the distance from to the line. Then F is the coordinates of the foot here. So we know that AF is perpendicular to the direction of the line. Alright, so what we have here, A is 302. Then F is the general point where we don't know the value of the parameter here. We don't know the value of t. So we can just treat F as 2 plus t, then minus 1 plus 2t, then 3 plus t here. Alright, so that's F here. So now what we know, we need to find AF, then we also find the dot product between AF and the direction of the line, so that we can find the value of the parameter here. Alright, so AF is F minus A, which is going to give us minus 1 plus t, then minus 1 plus 2t, then 1 plus t here. We are just subtracting the general point minus the point that we need to find the distance from here. So now the next thing is to find the dot product here. So A, F dot, the direction should be equal to 0, so that we can find the parameter here. So we are taking our AF dot, the direction equals to 0. So this is going to give us minus 1, minus 2, minus 1 here, plus t plus 4t plus t is equals to 0. So you can now see t is equals to 1 over 3. Alright, so t is equals to 1 over 3. So t equals to 1 over 3 is a parameter which is satisfying a scenario where AF is now perpendicular to the line that we have here. Alright, so with t equals to 1 over 3, we can find the coordinates of the foot by substituting into the line or the general point here. Or we can find the vector AF here by just substituting into AF, and also find the modulus of what? Of AF. Alright, so we are now substituting t into AF. We are going to have by substituting t into AF, this is our AF, so we substitute here. We are going to have minus 2 over 3, minus 1 over 3, and 2 over 3 here is the vector AF. So the distance now from A to F, we are just finding the modulus of what? AF here. So modulus of AF is going to be the component of x squared plus the component of y squared plus the component of z squared, which is going to give us root 7 over 3 units here. So that's the shortest distance. Alright, so now we go to the second part. Find the vector equation of the line passing through the point P, passing through the point A, and it's perpendicular to L here. So we need the shortest the vector equation of the line passing through the point A, and it's perpendicular to L here. So let's see here how it looks like here. So we have the line that we have here, and this is our point A. So our point A is 302. So the line that we need is passing through the point A, and is perpendicular to this line here. So which means this line here will be just continuous like this. All right. So this line will be continuous like this. So if you look closely, you can see that the direction of this line will be in the direction of AF. So that will be our direction. So the direction will be AF, and our fixed point on the line will be 302. So you can see that our vector AF here is minus 2 over 3, minus 2 over 3, then minus 1 over 3, then 2 over 3. That's the direction AF. Then our fixed point is what? It's 302. So now we can just write the equation. So the equation is r is equals to 302, which is our fixed point, plus the direction here. So the direction vector here, the vector which is perpendicular to this line L is minus 3, minus 2 over 3, and minus 1 over 3, and 2 over 3 here. So now we can adjust here by multiplying with a certain constant so that we can have the whole numbers here. So you can multiply by 3, is still the direction here. Or we can multiply by 6, is still the what? The direction, right? So that we can remove the fractions here. So this becomes r is equals to 3 over 2 plus lambda minus 2 minus 1 and 2 here. So the line is r is equals to 3 over 2, 302 plus lambda minus 2 minus 1, 2 here. So this is the line which is perpendicular to the line L, and at the same time is passing through the point A here. Alright, so you can now practice these two questions. If you meet any challenge, feel free to kindly contact me on the contact below. Thank you so much for watching the lessons, and see you in the next lessons.